I'm going to go ahead with the meeting beginning ritual. 起立，面向佛堂，参加先鞠躬，一鞠躬，再鞠躬，三鞠躬，参加各位的传习鞠躬，开班一鞠躬，请坐下。So here's a question that was asked. I'm grouping the questions together and trying to kind of summarize a question for all the people who raised that question. Can the Tao provide us with insights into quantum computing like an updated version of the Tao of Physics? So here I have the latest cover of the Tao of Physics. So this is just a little background for people who are not aware of this particular book. You can see this is the 35th anniversary edition. So it's been in print for decades now. Every time they have this anniversary edition coming out, the author, Fritjof Capra, will write a new preface to the edition, updating the content of the book to the latest knowledge in the cutting edge of physics. So the author is a mainstream scientist with impeccable credentials. And what he taught, he really has a way of explaining the Tao in everyday terms and also physics in everyday terms. So he's a natural author for a book like this. And the book has become very popular, which is why it gets all these different editions. So at the time that it was written, there was no real inkling of something like quantum computing that's become popular only recently. I would say probably in the last 10 years or so. So the book doesn't talk about quantum computing, but as Dr. Capra points out, there are numerous parallels between the Tao and modern physics. So at the heart of quantum mechanics and modern physics is the duality. Like photons have this duality that they can be waves or particles. And that maps really well into the message from the Tao. So then the question is, what about? What about something new? Can it be updated for that? So moving on. This is just to point out that Fritjof Capra was not the only scientist who noticed the many parallels between the Tao and physics. So one of the titans, one of the giants in the field of physics, Neils Bohr, he's easily at the same level as the other giants like Newton and Einstein and all the other big names that we know about. If you study physics, you can't help but come across the Bohr model of the subatomic world, and he is. The more you study his work, the more incredible this man is, and this is the reason why he won the Nobel Prize in Physics in 1922. And a couple of decades after that, the King of Denmark knighted him with the what they call the Order of the Elephant. You can tell in this crest, in this family coat of arms at the bottom, there's an elephant. So that particular order is usually reserved for royalty, and therefore not usually given out to a commoner like Dr. Bohr. But the king explained that this honor was bestowed to not just Dr. Bohr, but also to Danish science overall. So part of the process of being knighted is that you create a coat of arms for your family. So what he did was that he said, well, I'm going to design something that's meaningful to me. So he put in the yin and yang symbol. So if you were to travel to Northern Europe and you visit some of these places that have a statue of Niels Bohr as a revered physicist, you will see the yin and yang symbol there because it was of personal significance to him. So, he's another example of a physicist who saw the connection between cutting-edge physics and this very, very ancient concept of the Tao. So this leads to the question. So we have all these parallels, so isn't it reasonable to assume that there's some kind of connection between the Tao and quantum computing? And here I have a wild speculation down here for everybody. Could it be that the human mind is basically a quantum computer? So, I have plenty of friends who love these topics. They enjoy exploring the Tao. They enjoy reading up on science. They watch Star Trek. So when they get to this, they're like, whoa, dude, you just blew my mind. Is it possible? So I do have the answer for you. Maybe not the answer everyone is looking for, but I do have the accurate answer. Now, I think the reason that prompted this particular question possibly is recent news. So generally speaking, people who are interested in Tao are intellectually curious and they're looking to all kinds of things, which is why they read up on science, they're interested in what the particle accelerator is finding out about the nature of our reality, and if what they're finding out can map really well into the ancient belief of the Tao, bonus, that's gravy. So there's an intersection in my audience that I'm very much aware of. So let's go to the next slide. I'm trying to not keep everyone in suspense. Okay, so what is quantum computing? Now, this question was raised recently with superstar politician Justin Trudeau. Justin Trudeau is the Prime Minister of Canada. So when he visited this particular institute for physics research, question was raised to him. So you can tell us, Mr. Prime Minister, you can tell us something about quantum computing, right? And the question was asked in jest because most politicians would be like, oh, wow, yeah, whoa, I'm not a scientist, okay? I'll leave all that to the eggheads, our esteemed scientists, to answer that question. Now, what the reporters did not realize was that Justin Trudeau is a man of intellect, that he's intellectually curious. He reads up about this stuff also. Even though he's not a scientist, he has some basic knowledge and a high degree of interest about it. So he's like, whoa, you'll get me really excited now. And he's very composed when he provided his answer. So in this little internet meme that's passed around, Canadian Prime Minister Justin Trudeau stuns all with quantum computing. And that's because he's like, oh, you'll get me all excited about it when we talk about it. Regular computer bits is either 1 or 0 with quantum states. What quantum states allow for is much more complex information to be encoded into a single bit. So that totally went viral. It went around the world. Justin Trudeau received a lot of praise. There were people who say that, oh, he's a bit of a genius, isn't he? And there are people that just love the fact that you have this guy in politics who actually knows something other than politics, knows something about science. So he deserves a lot of applause for that. Plus, he is bringing attention to these research areas that previously have not received a whole lot of attention or public enthusiasm. Now, a lot of that enthusiasm is due to his model-like good looks. He's a rock star. He's got tons and tons of female fans, and so they follow every step. There's a tweet from one particular female fan, I think an American, this lady who says, if Justin Trudeau, runs me over with a truck, I would actually get up and thank him. Thank you for running me over, because she's such a big fan. So anyhow, the scientists themselves have nodded in approval and said that, oh yeah, he's essentially correct. Even the people that actually do quantum computing research say that he's essentially correct because they don't want to mess it up. They don't want to mess up all that positive energy by saying that, oh, actually, it's not, he doesn't know what he's talking about. That would be way too bad of a strategy to appeal to the public. Now, what I'll tell you is that he deserves a lot of credit for saying what he said, especially since we have so many politicians in our country who will say, on the one hand, I'm not a scientist, but then on the other hand, they'll say, well, but I don't believe in the science that the scientists are telling us about climate change. That's so bogus. But wait a minute, you're not a scientist, so how do you know? Well, I just know. So it's a very different thing that he has. Now, what I'm pointing out, though, is that it's kind of the Star Trek level of physics, where Captain Picard says, yeah, you know, the inverse polarity tachyon beam, just fire it at the time distortion in the continuum, and that will repair the rift, something like that. You know, so in Star Trek is known for a lot of techno-babble that really bears no resemblance to reality. Now, they know what they're doing, though, in Star Trek, because they know they just have to make it plausible enough to pass muster so that most people won't question it. And then they'll say that, hey, we have science experts who will advise us on the accuracy of the science. So you would assume that it must be accurate. But there's no tachyon, there's no tachyon beam, there's no space-time disruptions, no rips in the continuum for you to fire upon. So this is Star Trek physics. Okay, now, so let me explain. A bit in regular computing is indeed 1 and 0. A bit in quantum computing is called a qubit. Qubit, for the super nerds, is also a currency from the 1980s version of Battlestar Galactica. If you don't know what that is, that's okay. That just means you're not a super nerd. So qubit is not something that stores a lot of information. What it is that it's got two things that are central to quantum computing. What's superposition? It's just like the wave-particle duality of photons. A quantum bit, until it is measured, it can be both states, 0 or 1, and neither states at the same time. In quantum computing, there are multiple interpretations for that. One interpretation is that, you see, when you measure something, it collapses the waveform, the probability waveform, and you'll find out which universe you actually live in. Prior to the measurement, actually the universe diverges into two different paths, one where the result is 1, the other one where the result is 0. Therefore, the multiverse. Therefore, the multiverse has an infinite number of branches ever since, you know, the beginning of time, the Big Bang. There's just this grand design of incredible complexity, infinite complexity, in fact, where the universe is not just a universe, but one of an infinite variety of universes. Entanglement, that just means that when you have two particles that are entangled with one another, no matter how far apart they are, whatever happens to one is instantly reflected in the other. And the way that I can explain it is that if I have a very long rod and I turn that rod on the one end, the other end is going to turn with it at the same time. Here, though, it's something that's always caused an issue within the physics community, because it doesn't matter how far apart the particles are, a change in one automatically is reflected in the other, even if they are galaxies apart, tens and thousands, millions of light years apart. The result is instantaneous. It's what they call a non-local phenomenon. So zero time is an issue only because the information seems to be transmitting instantaneously and faster than light, and nothing should be able to go faster than light. But this is what we're working with. So why do we even care? So think of the qubit as a question mark, not as a 1 or 0. It's a question mark that becomes 1 or 0 when you actually measure it. Why is that useful? Well, when you need to factor very large numbers, that comes in handy. For certain kinds of calculations, it comes in super handy. And quantum computing, much faster than classical computers, when you get the number of bits entangled to increase, the more you entangle pairs of quantum particles, the more powerful quantum computing becomes. World record today is 12 stable entangled particles done by MIT, and there's another record at 14 entangled particles, 14 qubits, and that's another research institution. I don't believe they have the same stability as the MIT results. What it means by quantum supremacy is that as the quantum computing capabilities increase, when you get the qubits to be entangled in stability with one another, that it gets to the point around 50 qubits where conventional computing can never catch up. That no matter how much computing power you have with our fastest supercomputers, it will be surpassed by a long stretch by quantum computers. So scientists believe when they get there, they will be able to basically crack all the encryption schemes in the world, which depend on the factoring of large numbers. At the same time, quantum computing will also allow them to devise uncrackable algorithms, uncrackable encryption. So that's why it is so important. So we've spent about 10 minutes on it. I can answer additional questions offline. As you can see, it's a fascinating topic to super nerds everywhere, but I don't want to spend too much time on it because there are other questions that we need to ask and answer. So these terms, I hope, will pique enough interest in you to look them up later on. Quantum supremacy, that sounds really cool. Like, you know, hey, I saw this movie with Matt Damon with Born Supremacy. Is that similar? No. It's actually very different, but if you were to look it up, I think you will find that the topic is fascinating. What does all this quantum computing stuff have to do with the Tao? Actually, not much in a direct sense. Like, it's not something that speaks directly to the Tao, or there's not a chapter in the Dao De Jing that we can point to and say that, hey, look, it's just like quantum computing, or predicts quantum computing. Okay, so I'll get that out of the way. So what about the mind of consciousness? Is the mind a quantum computer? Well, no, not really. Unfortunately, not. There's no quantum computing that actually happens in the human mind. There isn't anything in the brain that is small enough to have quantum effects. So take the smallest brain cell, it is still huge compared to the scale of, like, you know, microprocessor. The traces on that are subjected to quantum effects and therefore have fluctuations. While compared to that, the human cell, every cell, including brain cells, is macro. It's much bigger and it's much more stable in the quantum sense. So there's no quantum effects anywhere in the brain. Not only that, but the factoring of large numbers that quantum computing excels at, it's the kind of problem that we human beings do poorly at. We're really bad factoring large numbers. It takes us a long time to even factor a relatively small number compared to what computers can do. Computers are really fast. So if the human mind has some sort of quantum computing going on, you would expect the opposite. You would expect that we will be really good at factoring large numbers. That's not the case. So that's my answer. Quantum computing, not a whole lot to do with the Tao. I know it's a fascinating topic, and the Canadian Prime Minister, yep, he's a rock star, and he brought much needed attention to the research, but that's about as much as we want to talk about that particular topic. Hopefully that's the last word. Let's go ahead and do the meeting ending ritual, everybody. 起立，面向佛堂，持架三鞠躬，一鞠躬，再鞠躬，三鞠躬，持架规则是一鞠躬，接班一鞠躬。Okay, everybody, we are done.
Participate in the Tao meeting by joining us online. For information, go to taoism.net/Tao.